Hi, my name is Pavel Savyankov. Welcome to new Cube video. Today I show you how to filter elements in a CubeGUI. Let's do it. Okay, we are back to our terminal, and today I would like to show you how filtering is working in the CubeGUI. Although filtering might be a too general term, it suggests that we can formulate some complex criteria and decide whether one element gets shown or not. In our case, this criteria is very simple. It's simply threshold, and we compare basically, do we want to display some element or some value or not based on threshold. Currently it is implemented like that. Whether we extend this feature in a more general manner, we will see. Till now, more than that was never needed. So, where do we find this filtering? Well, filtering of metric tree doesn't make much sense because metric tree is relatively small and one is interested in every metric usually. Filtering in system trees also has less value because we actually interested in distribution of values across the system. We do not want to hide some elements based on its values. So therefore our filtering is applied, or most useful is in a cold tree or in a flat tree. So I will show it in a cold tree. So that's an example of our cube file, BTMZ benchmark. And so if we expand the call tree a little bit, we see the values. Some of them are relatively large. For example, metric time, it is 160, so 800, and so on. But some of them are really little, really small. And of course, in the context of performance analysis, these regions, they are not interesting. They rather disturb our view and drag our attention away from the actual performance relevant call path. So what one can do, one would like to actually hide them. That's exactly what it is. If we're looking for this feature, we have to look for hiding. That is in context menu, and we have here dynamic hiding, static hiding with some elements, and no hiding. As default, as we see, no hiding is applied, so everything is shown as it is, and user has to basically orientate himself in a call tree on his own. The call tree, this example is of course relatively small, but one can easily get a call tree with more than 100,000 elements, and one gets lost relatively fast. So let's take a look at our hiding. So as we have seen, there is dynamic hiding. What does it mean exactly in a minute? Here is static hiding, and with explicit hide this and show children of this. So probably, or probably for sure, it relates or refers to the element on which one clicked the call to context menu. So if we call context menu in empty space, these elements are disabled, so they are not available. Of course, this word this refers to the selected element. So let's take a look on our call tree. We see that this element is relatively big, but these all are so small, and these are so small, and well, this is relatively big, and this is big. So that's the metric time, and maybe we are not interested in all other the small elements, so we would like to hide them so that they do not clutter our display. So let's go on, for example, environment setup contributes very little. So okay, we can go to hiding and hide this, and it's gone. We can do the same with zone setup. It's obviously not interesting. Map zones is not interesting. Probably we can do also multiple selection. No, we cannot. Then we have to do it one by one. So, and in this way one can hide relatively slowly and manually all elements which on which one is not interested. One can notice that in a parent of all these elements one gets additional information, 8 hidden children, which means, so in this value which is displayed here as exclusive value, so 4.6405, this consists out of own value, own exclusive value, plus the contribution from 8 hidden children. How big is this contribution, we don't know. We are also not interested in it because that's the reason why we have hidden these children. We know only that the region main, its exclusive part, plus these hidden children are, together are 4.6. So, and this hiding, so these 8 hidden elements, they stay hidden even if I select another metric and explore performance data. So these hidden elements are hidden. That is the reason why they are part of static hiding. So the hiding here is static criteria, or our selection doesn't change with any another our selections. So if we would like to see these children back, we can select the hiding and either no hiding, or we display children of this element, hidden children of this element. Yeah? So like, let's take a look. So for example, I want to hide also this element, so hide this. So we see that here are 8 hidden children, here is 1. So if I would like to see these 8, but I would like to keep this one hidden, I select this main, go on context menu and show children of this. So it displays all these hidden elements of this element of the main, but keeps the hiding of other elements of ADI. If I would like to display back all elements which I have hidden before, so I just go into hiding and select no hiding, so everything gets shown. So criteria is basically set to 0. So that is the one way of decluttering our call tree. Another way is to set threshold actually. So for that, if we select elements, so here is for example 12, we see that it is 1% of the total value. Here is the 11%, or one can select here display, different display, own root %. This feature I will explain in another video. And we see that, for example, this value is 6% of the total. Here is a 1% of total. Here is 0.2. Here is 11%, 22%, and so on. So it looks like a reasonable threshold for our display would be something like under 6%. Then all the small values they will go away. So for that, we can go to hiding and we select static hiding. And here we get a input field where we can set percentage of the color scale, which goes like from 0 to 100. So in this case, we would like to set a 5%. The title of dialog is misleading, has to be fixed. So it is static hiding. And we set a 5%, okay, and it gets applied, and we see that only elements with the values which are above 5% of the root, they state basically. So, but we see also the status of hiding. So basically, the value of 15 here, it's a result of the hiding. So it's own exclusive value plus collective accumulated contribution of 13 hidden children. Here it is, one got 4 children hidden, and here is 1 child. So again, that is static hiding. It means that if we select it now another metric, like for example visits, we see that value have changed, and we can compare it again. And we see that, for example, there is one value with very little percentage, but this value stays displayed, so it's not gets hidden. That's the meaning of static. The criteria, hiding criteria, were selected for the metric time, and they were applied only once, and the selection or this hiding state stays constant despite our further selection of the metric, or we expand the elements, so they are not hidden because they are displayed, they are now visible. So that's the meaning of static. It's useful if one has hidden some elements on some expansion state of the call tree, and one would like to see how does it affect or how does it corresponds to some values of another metric. If one doesn't want this hiding anymore, or one would like to reset the threshold, like for example here, so one goes to hiding and sets the redefined threshold, let's say 6, and it gets recalculated and again hidden. The elements get hidden. So that is static. As you have seen, the criteria gets applied only once, and it stays like that. So with no hiding, one removes it. The counterpart of static is of course dynamic. So it works in very same way like static hiding. So if we click on dynamic, we can select here, for example, 5%. This time the dialog is titled correctly, so 5%. And threshold gets applied, so every element which is above 5% is displayed. In dynamic hiding, as it says, the hiding gets recalculated and reapplied every time we select new metric, or we expand elements and change tree in another way. That is the meaning of dynamic. So we can go at delay cost, for example. This 5% threshold gets calculated and applied, or we go into the metric time, it's also applied, and visits, it's applied like that, and we see that it shows only elements which value is above 5%. Here one can notice that it doesn't show anymore the number of hidden children. It's more value centric. So it states, like for example here, 30% hidden. It means that out of this value, which is displayed 5 dot, let's see that here. So out of this value 6.7, 70,000. The 92% is contribution from its children. So and only 8% or 7.7% is the own value of ysolve. Here is the 97% of this value is coming from children, and so on. So it's a little bit different interpretation than just number of hidden elements. So, because the dynamic hiding is more value centric. So I hope you like this feature, and it helps you to analyze performance data more easily. Give us a comment, like, and subscribe, and see you next time. Bye.